Good morning. Welcome back to my YouTube channel. Once again, this is your host, Santos Capitan Jr. Always wishing you a good day. Guys, today what I'm going to do is to continue my tutorials for practical tests that an applicant like a BMS engineer, applicant or a BMS foreman or technician that might encounter. Okay, so especially if you are applying for a BMS engineer post, maybe one of the practical tests that you will encounter is this logical gauge. Okay, so today our scope is to discuss this logical gauge. As I said here, logic gauge used in control logic programming. Okay, so as a BMS engineer, one of your roles is to program the control logic for a certain or for a specific HVAC equipment like exhaust fan, kitchen exhaust fan, air handling unit, chilled water system, pumps, and so on. Okay. So our topic for today is logic gates. Okay. So what are these logic gates? Okay. As you can see here in my screen, I have several logic gates here, but I will focus here the most commonly used or the gates that I'm using in my uh, Menta editor or my engineering tool. Okay. So I have an engineering tool. Let me show you my engineering tool. Okay. Share. Now this is my engineering tool. Okay. This is called Menta programming. This is a functional block programming. Okay. So there is a block like this one, digital input block. Then there's also a digital output block. But the discussion of this will be on the next tutorial. Okay. Now my concern here is to explain to you this logic gates. As I have shown you in the previous screen, the logic gates that is being used in control logic programming. Now I'm in my control logic programming editor. So I have here the AND gates, okay? I have here the OR gates, then and the NOT gate, rather. Then I have my OR gates, then I have my exclusive OR, okay? So let me go back with my previous screen, okay? Now, so this is the logic gates. Because as I said, if you are applying for a BMS engineer post, then you might have this practical test. Maybe the guy who is going to test your capability as a BMS engineer, he will give you this. Okay. Now, actually, guys, this is just for beginners. Okay. Now, if you are already a BMS engineer, then you are applying for a post, you might encounter this. But if the company knows that you have a good experience, then maybe you will not encounter these things. Okay. Maybe they will give you a much more difficult scenario or test. Okay. But this is for beginners. Okay. So what are the logical gates here? So we have here the not, the and, the NAND. NAND meaning not and, okay? Then or, then nor, not or, okay? Then exclusive or, then not exclusive or, okay? So let's try to see the each of one of these logic gates. Okay. Now, what is important in logic gate is to understand the truth table. Okay, so right below here I have the truth table. Okay, so let's talk about this NOT gate. Now, also there is an algebraic expression for that one. So this is the algebraic expression, but my concern for today's video tutorial is to explain to you the gate and the truth table. Okay. Now, for the NOT gate, we have one input and one output. Input is denoted by capital A, then the output is denoted by small letter x. Okay. Now, the symbol is a triangle. Okay. Then there will be a small circle in front of this triangle here. This portion, you have this portion. That one denotes the not, okay, or the negation part of the gate. As you will notice in the not end, there is also a small circle, okay. Then also here, we have a small circle here to denote the negation, okay, or the negation of the output here also. So meaning we are going to negate or invert the output. Okay. Now, let's talk about the truth table. Now, this is very important for an engineer who is wishing to be a, to become a BMS engineer. Okay, so we have here our input, okay, column represented by A. Then we have our output column represented by X. Okay, now we will have different scenarios. When I say different scenarios, we will have different input. So let's say we have an input signal here of 0. Now, these signals, we already discussed the different type of signals in the previous tutorial. Let's say coming from a differential pressure switch, we have a digital input signal. So when you say digital, again, the possible values of that signal is 0 and 1. That's why here we have a NOT gate. So we have here, so this is digital, okay? So we have an input 0, then let's say the input here is 0, then the output will be 1. Why? Because we are negating or inverting the input. So if you input a 0, then the invert of that signal will be 1. So that is the function of this small circle. Okay? So meaning, if you have an input of 0, then the output will be 1. Then if you have an input of 1, the output will be 0. So if you have 1 here, the output will be 0. If you have 0 here, then the output will be 1. That's very easy. I hope you get the concept. Okay. Now let's go to the end. End. Okay. When are you going to use the end? Now I will explain it later. Okay. Now I have here the symbol. Make sure you are using, if you, let's say, if you are writing a control logic program using the simple logic, make sure you are using the correct symbol. Okay. So what is the symbol of AND gate? We have here, this is the symbol. Okay. So now the algebraic expression is A and B. Now, for the truth table of AND gate, we have two inputs, A and B. Then we have one output denoted by X. Okay? So let's have different scenario so that we will understand the truth table. If the input are both 0, 0, A is 0 and B is 0, the output will be 0. Okay? So let's say we have an input of 0 in input port B and we have 1 in input port A, then again the output is 0. Then if we have an input of 1 in B and 0 in A, again the output is 0. Then next scenario, if we have one input in B and one input signal in A, then the output will be 1. Now we can say directly that we need two inputs that are 1 before we can have an output of. So that is the truth table. So meaning all the inputs should be 1 before I can get an output of 1. Okay, so that is an AND gate. 1 and 1 will be 1. So that it's like saying both inputs should be 1 before I can get an output of 1. So any of the inputs becomes 0, automatically the output will become 0. So that is an AND gate. I hope you get the concept of an AND gate. Okay? So later I will show you how are you going to use it in your control logic program. Okay? Now we have here a NAND gate. Okay, NAND gate is just like this. You have to invert or negate the output. So let's see the truth table. So both inputs are 0. If it is an ordinary AND gate, it will give a 0. But it is a NAND gate. So the output 0 will be inverted to 1. Okay? Then 0 and 1, 1. 1 and 0, 1. Then 1, 1, 0. So as you can see in the NAND gate, if the output is 1, because both inputs are 1, then that's the only time it will become 0. I mean, the output will become 0. Okay. So that is the difference of AND and NAND. AND gate and NAND gate. So it's very self-explanatory. If you have both 0 inputs, then you will have a 1 output. If you have a 0 and 1 inputs, then you will have a 1 output. 1 and 0, you will have a 1 output. Both inputs are 1. Both inputs here are 1. Then that's the only time you will get a 0 output. Okay? So that is the difference of AND and NAND gate. Now let's go to OR. OR gate, algebraic expression is A plus B. Okay. Now, again, you can see the difference of this OR gate symbol than the NAND gate. Again, let me reiterate, if you are uh, writing or preparing your control logic program using the logic gates, make sure you are using the proper symbol. Okay. Now, let's see the truth table. Input B and A, then output is X. Now 0 and 0 will give us a 0. 0 and 1 will give us a 1. 1 and 0 will give us a 1. 1 and 1 will give us a 1. Okay. So meaning, it's just like saying, if I have a 1 input, automatically I will have a 1 output. So 1 inputs become 1, then automatically I will get 1. Okay. So if 0, both 0, then that's the only time you will get a 0 output here. Okay. So that is an OR. Now NOR, not OR. Again, you will notice this is more circle in front of the output. Okay. So you are just going to negate the output. So 0, 0, 1, that's correct. 0 and 1, that is 0, because you ordinary or you will get 1, but you have a NOR not here or a negation here, so it will become 0. 1 and 0, ordinary or it will become 1, but you have but this is a not, so it will become 0. So 1, 1, it becomes 0. So that's the only time that you will get a 1 output when both inputs become 0. Okay, so that is the NOR gate. Okay. Then what is an exclusive OR? Exclusive OR, okay, so the symbol is like this, just like the OR gate, but there will be like another line here. Okay, so exclusive OR 0, 0 is 0. 0 and 1, you have 1. 1 and 0 is 1. Okay, but if you have a 1, 1, you will have a 0. So that is exclusive OR. Okay, so just take note of the inputs. If both inputs are 0, then you will have a 0 output in exclusive OR. So it's just like an ordinary OR for 0 and 1, 1 and 0. But notice the difference. 1 and 1 will give you a 0. Instead of in the ordinary OR, we will get a 1. Guys, so that is exclusive OR. Then exclusive NOR. Okay, so again, there will be a negation here. 0, 0, it will be 0 in exclusive OR, but we are negating it, so it will become 1. So 0 and 1, it will become 1 in exclusive OR, but we are using the negation, so it will become 0. 1 and 0 in exclusive OR is 1, but we are using the negation here, so it will become 0. So 1 and 1 will become 1. Okay. So basically, this will be the logic gates that you will encounter in control logic programming. So as an applicant for BMS engineer post, maybe or maybe a BMS supervisor or foreman, you will encounter also this practical test. So he will give you the logic gates, then he will tell, the examiner will say, okay, give me the corresponding truth table for this NOT gate, AND gate, NAND gate, OR gate, NOR gate. Okay, so guys, this is one of the possible practical tests that you might encounter if you are applying for a BMS engineer post, or maybe a BMS supervisor or a BMS foreman. Once again, I hope you grasp the concept of logic gates, because these gates you will be using it in our functional block programming if you are going to write the control logic program that will be uploaded in a controller. Okay, let me show you the equivalent symbol used in my Menta programming. Okay, so I have here the AND gate, the NOT gate, the OR gate, and the exclusive OR. I don't have the XOR. I don't have the NOR. If you will be needing a NOR, then maybe you can use this NOT gate here. So you can connect this here. Okay. So whatever output here will be input here, then it will be negated. Okay. So I hope, so even though there will be no available uh, gate for exclusive or like this, okay, and NOR gate, then you can always use this NOT gate, okay, in combination of this gate. Like NAND, we don't have a NAND in this functional block, okay, simple block. I don't have here a NAND. Do I have a NAND here? So let me type here if I have a NAND here. NAND. Okay. Okay. So meaning there is a block for NAND. So if you want to use a NAND, you will use a combination of this and NAND gate here. Okay. So my next tutorial is I'm going to show you how are you going to use the gates in control logic programming. Okay. So let me go back to my previous screen, because this is the scope of this tutorial. So once again, if you are new to my channel, guys, you can always help me by promoting my channel. If you will like, put some comment, then subscribe. So this is Santos Capitan Jr. Always wishing you a good day, and I hope for those new engineers, if you are planning to join an MEP company, these tutorials will be very helpful for you. So once again, Santos Capitan Jr. is not claiming any expertise. I'm just sharing something for those beginners. So again, before I will end this tutorial, God bless us all. Let's all be safe and bye for now.